Okay, so we don't have that much time. So I put up the SAT practice. There's like a past paper SAT on the US Universities channel, and also AP Calculus thing on the channel. Yeah. So I guess there's some questions that we can look at together. Could be kind of fun. But today, I guess, depending on what time we have, I just want to talk about this geometric series, yeah? The ratio test. So ratio test is in this AP Calculus course, yeah? But what's in our course is geometric series. Remember the 2-unit maths? Geometric series, yeah?
Oh, yes. A financial maths moment.
Yeah, so it's either geometric or arithmetic, yeah?
Or it's not series.
And series means it's a sequence of sums, yeah? Okay, so remember this. You remember this, if you plus 1 plus x squared plus x to the n equals 1 minus x to the n or 1 minus x, yeah?
Yeah.
Huh?
Yeah. M plus 1.
1 plus 1, yeah. Okay, so this thing has a limit, you see?
It is
if
what?
x Okay, so if x is less than 1, yeah?
Yeah.
Then there's a limit, yeah?
Yes.
Then this goes to what?
AR.
I'm doing this.
Oh,
I can't just remember formula.
About that. So it's
I got that in, bro.
if x is less than 1,
Yeah.
Seems legit.
then
So
that goes to 1 on 1 minus x.
If x
Yeah,
is
so this goes to 0, right?
less than 1, then it goes to 0.
So 1 on 1 minus x, yeah? Okay, what if x is greater than or equal to 1?
Then it goes to infinity.
Then what?
Wait, no.
Then it just goes.
Okay, what if x is greater than 1?
It just goes broke.
It doesn't converge.
It diverges, yeah?
It goes broke.
It's obvious from the formula diverge, right? But if x is equal to 1, the formula can't tell you that. So what happens if x equals 1?
Then you just use the thing. It's just
integral.
what's it called? It's just n.
Okay, if x equals 1, it's n, right? What if x is minus 1?
Wait.
Then it's 1 or...
Oh yeah, you use the integral thing.
Wait, no, this is like an infinite sum. 1 plus 1.
Yeah, it is. 1 at 12. It's like 1
No, negative 1
No,
at
it's a half. It's a half.
Harmonics.
What?
1 minus 1 plus 1 minus 1 plus 1 minus 1.
It's famous in that it's very common, but what is the limit though?
112.
There's no
Negative 112.
Negative 112.
Negative 112.
I don't think.
What? Where are you, like, how can you...
What is this?
How can you just quote these memes in the class? They're so, like, unmathematical. It's like, and it's not even like you're quoting it directly.
The limit doesn't exist.
The limit doesn't exist, right?
Because
Because the limit simultaneously like 0, 1, minus 1, yeah?
Hello. What have you done with the Leon?
This one you actually, like, sometimes if it's 1, if it's negative, it actually kind of equals infinity, whereas this one, like, if it's negative 1, it's like it just doesn't exist, yeah? Okay, so here we have this thing.
It's called breaking the system.
Yeah, so
Negative 112.
this is basically the 2U syllabus, right? If you apply this to finance, then that's just the 2-unit syllabus. And an arithmetic series is trivial, yeah?
Yeah.
Okay. So now in the AP syllabus, there's a thing called the ratio test. Okay?
What's the ratio?
Oh.
The ratio test. So if you have a sum, yeah? And you're summing up stuff of the form like AI, and I equals like 1 to infinity, yeah? Yeah. So the ratio test tells you when this is convergent. Yeah.
Oh.
So this.
How did this happen?
So you take the ratio test. So what you're actually doing is you're taking the limit as n goes to infinity, a n plus 1 on a n. Yeah.
Mm-hmm.
And if this is less than 1, yeah,
Oh, that means it's decreasing. So it's converging.
then it converges.
Yeah.
Yeah.
Oh.
If it's equal to 1, it's unclear.
But if it equals.
Unclear.
Unclear.
Oh, sorry, absolute value. Absolute value.
Oh,
It's just unclear.
oh really?
Unclear.
And then if it's greater than 1, it diverges.
Yeah.
Have you seen this before?
Well, I mean, it's pretty intuitive.
Can you prove this?
Seems legit.
Seems pretty
Seems
intuitive.
Kind of approximating with the geometric series.
Oh, have you seen this before, Yasser?
Oh yeah, we did it last year. Yeah, we did. Yeah.
Oh, okay. Okay, so let's do a proof of this, yeah?
Okay.
So look at proof of this. Okay, so basically if it's...
So the starting terms don't really matter.
Do you know what limit means? It means like this ratio for sufficiently large n, right? That all like basically if the limit exists and is less than 1, right? It means that whatever the limit is, you can get as close as you want to the limit provided n is large enough. Yeah? Okay, so if the limit is less than 1, then you can get, so like if n is large enough, you can get it close to that number, right?
Yeah.
And so basically what you can do is if n is large enough, so suppose the limit's less than 1, yeah? Less than 1. So basically there exists an n such that for all n larger than this n, right? The ratio an plus 1 on an, yeah, is less than r, which is less than 1. Yeah.
Oh, right.
It's a fixed r for all n.
Yeah.
Okay.
Uh-huh.
So that limit is less than r. You can get it close to the limit, so it's going to be less than r. Yeah. Okay.
What's the definition of convergence? Closed.
So basically, you think of this r as like the ratio in the geometric series, right?
Yeah.
So this sequence is now kind of bounded by the geometric series.
Oh, it's geometric series.
Okay, so it's greater than
Starting
0.
So you can ignore the starting terms and then just go from where the pattern begins.
Yeah.
I hate these controls. Okay, unfortunately, I'm not.
Yeah, so actually, so this an is less than r times an. An plus 1 is less than r times an. So this sequence actually converges what's called absolutely. So this an is less than or equal to
Since I don't know how to do the second
a1 times r to the n. Yeah?
Yeah.
0.
It's just that's not one that converges.
Yeah, so this thing converges.
Visualize the wrong piece.
And the constant doesn't really matter. The A1 doesn't.
Yeah. Yeah, I guess the original sum is less than this.
Is this like squeeze? Squeeze.
So this makes it obvious that it converges if this sequence has all positive terms. So there's a kind of a famous result that's like if it's this is called absolute convergence, yeah.
Yeah.
So it's in general, if something's absolutely convergent, it's convergent. Wait, Yasser, do you remember a proof of this off the top of your head?
Proof of absolute convergence
implies convergence.
Let's see. So it's. Wait, I'll just get my things out. I mean, open the whiteboard.
All of them are positive. It's clear.
Okay, but let's put this on hold for now. So at the moment we showed it's absolute convergent, yeah?
So if it's
Okay.
absolute convergent, so when you have negative numbers, so it limits to 0, which means that you might have some alternating things. Where's the board?
Yeah.
I mean, it's kind of intuitively obvious.
Yeah. Okay, let's have a look. So if you have sum of like n I equals 1 AI, right? So you want to find this limit. You want to kind of approximate this difference. Yeah, L is whatever the limit should be. Guess. So you know that this is true. Maybe there's another L. That's a different L.
Oh yeah, it's another different. So AI.
Actually, another way of saying it is if you have this is convergent, you also have. Actually, I need to use this for later anyway. So when you have a series is convergent, right?
Yeah.
You know that the terms actually have to go to 0.
Yeah.
Okay. So if you have series is convergent, it's like if you have n minus so n plus 1 AI n, yeah. You know this. So like because they're both approaching the same limit, right? This when you have n plus 1 terms, it's going to be really close, and you have n terms, it's going to be really close. So those two is actually going to be close to each other as well.
Yeah.
So they're close to each other, but what is their difference? The distance is close, right? But the distance is actually just the last term, right?
Yeah.
So it's just equal to an, right?
Yeah.
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 So if you can get if for any epsilon you can go far enough and the term is smaller than epsilon, right?
Yeah.
Then basically that means that by definition limit AI equals 0.
Yeah.
Yeah. Okay. So okay, so this kind of quickly proves the other part. So because the terms have to go to 0, right? If the ratio test gives you something bigger than 1, right? You get that eventually like an plus 1, right?
Yeah.
Is bigger than an. Yeah.
Yeah.
And that holds for all n past a certain point, right?
Yeah.
Okay, and so these things cannot go to 0.
Yeah.
Because they're strictly greater than 0. That makes sense.
You mean that's the right?
Yeah.
Let's see. On the board, I'll be again.
Yeah, limit a going to 0 is the same as limit of the absolute value going to 0. The absolute value is continuous. Okay, so that proves if it's greater than 1, it diverges. Yeah. Okay. And if it's equal to 1, you have stuff like this. Like what's 1? Like this is a harmonic series, right?
Yeah.
We know that diverges. Yeah.
Yeah.
We proved that before. What's the ratio test for this?
It's
It's like n on n. No, wait. It's like n plus 1 on n.
It's like 1 on n plus 1 on 1 on n, right?
Oh,
It's n on n plus 1.
oh, so n on n.
Yeah, but in either way, the ratio test gives you limits 1, right?
Mhm. Yeah.
But it diverges, yeah?
Yeah.
Okay, and then you have stuff like n equals 1, 1 on n squared. What's the ratio test?
N squared on n. N plus 1 squared.
1 n plus 1 squared on 1
On
on n.
n, yeah. So it's like
Yeah.
the previous one squared. Also approaches 1. But that one. Does this one converge?
So this one, you see it converges, right?
Yeah.
Yeah.
Because it's bounded by the integral. Yeah. Yeah, actually, the way I'm thinking about proving so basically
Wait, I
we
remember the
showed
proof.
that.
Wait, I remember the proof.
Oh, good. Okay, good.
For
Okay,
absolute
and then
convergence.
one more before we do the absolute convergence is this alternating harmonic series.
Oh.
Oh.
That one.
That,
What's
that
that one?
converges.
What is the ratio test? It's also
It should work. That's where
It's negative 1 on n. Yeah. N plus 1, negative 1 n. And that's always gives you a negative then you want that. Negative.
so it gives you -1, right?
Yeah.
So when you do the absolute value, it gives you 1, yeah?
Yeah.
So this is something,
Wait, what is this?
huh?
First diverges, second.
Yeah, the first diverges, the second kind of really converges absolutely or whatever.
Converges like I squared on 6.
So there's a theorem that says like if something converges absolutely, so that obviously converges absolutely because it's all positive anyway.
Yeah.
Then you can reorder the terms, sort of.
Oh, interesting.
But here the third one is it's kind of conditionally convergent. We did this once in the holidays.
Yeah, I remember. This was.
It was like,
Oh, this was the holiday when.
yeah.
No, the first one we went online. This is
Yeah.
the first one where
So this one kind of does. So there's all these three cases are covered by ratio test gives you 1. So ratio test can't tell the difference with these three cases.
Yeah.
Okay, and then the only thing we need to do now is show that absolute convergence implies convergence. Take it away.
Okay.
Take it away.
Okay. So you have negative absolute value of. Or maybe could I share screen? Maybe. Actually, no. I think it should be okay. Okay. So negative absolute value of AK is less than equal to AK less than equal to absolute value AK. Now 0 less than equal to AK plus the absolute value of AK less than equal to 2 absolute value AK. And now do the sum of AK plus absolute value of AK less than equal to sum of 2. Actually, instead of that, it's say this. So the sum of this converges. There's 2 times the sum of this which converges. But then using the comparison test, I think it's called. Since this is between 0 and it's between 0 and this converging function, it means this sum converges.
Yeah, so basically, it's obvious that converges because the definition of real numbers is basically like if something's increasing and bounded, it's going to converge. And so if all the terms are positive, the sum is going to be increasing, and it's bounded by something, so it's going to converge. Yeah.
Okay, so now the next step I think was the sum of AK. Do something like this.
absolutely.
Oh.
So then you can do the sum of 2 sequences.
Oh.
That's a little bit tricky, yeah.
So it's
Yo.
dodgy is
So there's like limit
is
laws.
that stranger
Limit
than expected. Yeah. So saying if
Okay.
kind of F and
Can we apply this was?
So he's saying that we know that converges and that converges, so the difference converges.
Yeah.
The difference is just that original thing.
It seems like
Okay.
Proof by perception.
proof by observation.
Okay, that was a little bit sneaky. That was pretty cool. So that's something you can take home with you forever. Like it's not just like ratio test. I need to pass AP calculus. That's
AP calculus.
this absolute convergence thing is pretty can go quite far. Okay, so let's finish off that little section with. All right, do you guys understand what just happened there?
Yes.
Wow. What's ratio test? And then I found this random thing online with 5 problems.
Oh.
So
Let's do ratio.
this can be
Okay.
our like school maths.
So we did in uni last year.
The same ones?
I mean, these types of questions.
Oh.
Oh, okay. Well, there's only 5.
That's the best.
Ratio test.
I remember using it.
Let's spam some
Yeah,
ratio test.
everyone used that at some.
Okay. Should we divide and conquer or should we one each?
Yeah. How do we do it? How many? There's 5 people, right?
What?
Why is
Lucas
5 people?
is alive.
Oh, there's 5 problems as well.
Yeah.
I'm dead.
Lucas. Okay. Lucas, just go with Will. Okay. So
So it's
2,
what? N plus 1 on N.
I'll do 2.
3, 4, and then 5.
The ratio.
Yeah, ratio test is you
The
check
next term is like
I'll do one.
nk plus 1 and n minus nk, right?
Let's see.
Which one is Will doing? Oh, you have no idea what you're doing?
No.
It's like
That's not good.
you're fired.
Wait. Oh, wait.
Fire.
He's fired.
That was
Okay.
good fire. No one
Which
could
one am I
fire.
doing?
Wait. I'm trying to figure out how many people are in the room.
We have 6 people.
Reach the complex
Is
factor.
Anthony there? I think Anthony's there, right?
Yeah. Anthony's got question 2.
And is Leon there? Is Leon there?
Yes.
Yeah.
Leon's got question 4.
Does Alex exist?
Just one.
Alex got question 3. Daniel's got question 5.
1 9.
Will's got question 1.
Lucas exists. Lucas.
I got question 5. What?
No, this looks sus.
No, I got it.
And look, the solutions are here.
Wait,
I
feel like
forgot.
So we can look at how to do it before we do it, because we wouldn't be able to do it the first time by ourselves.
For 2, it's greater than 1.
This is less than 1. So wait.
Just
Oh.
limit it as it goes to infinity.
Okay, we have a claim for 2. 2, you're saying 2n plus.
Oh wait,
1.
question 3 is like cool because you can just minus 1. Wait, n equals n minus 1.
Yeah.
And then it's clean.
Oh.
Damn.
Is this less than absolute wonder?
Oh wait,
Hmm.
it's divided.
2, that doesn't
change.
is that not
Holy
less than
crap.
absolute one? What?
That's a lot of n's.
Is that not?
No, because this looks sus.
Just like
This.
That's greater than 1.
Okay, the 5n part should be easy.
Time to use calculus.
Cal-
AP calculus.
What?
2.
Wait, yeah.
I mean, calculus even has calculus.
Oh,
That's not negative.
perfect.
And
Kind of setting.
oh, I think this is just a picture, right?
Yeah.
Times.
So that's like less than one.
Build a PC set.
Less than one.
Yeah, so this part just goes to 1, yeah?
Right, so
And this is greater than 0.
yeah.
This has to be greater than
Oh,
0.
what is that? Oh.
So that's by squeeze.
By squeeze.
Proof by squeeze.
Proof by squeeze.
Okay, and then what's 2n plus 1 factorial?
What? 2 times n.
One.
Ooh, damn.
Wait,
Oh wait, that's just 2n plus 2 times 2n plus 1. Then, yeah, 2n plus 2 times 2n plus 1.
2n plus 2, 2n plus 1.
This is like induction moment.
2n.
School maths induction moment.
Yeah.
Really?
Yeah, so many induction proofs are like.
Wait, and then this just goes to infinity.
Yeah.
Oh yeah, that goes in. Which
Which I guess counts as more than one. Alright, Anthony takes the lead.
That definitely goes into the ask me
as well, I think. I'm not sure how rigorous it is though.
Alright, what was your one?
So we did number 1.
3 to the 1 minus 2.
2 and plus 1, yeah. Divided by n plus 1 squared. Plus 1 divided by 3 to the 1 2 divided by n squared plus 1. Don't even bother expanding.
Yeah.
Equals do the flip. So it's 1 on 9.
Oh, what? Oh, 1 on 9.
Yeah, just like top and bottom.
1 on 9.
Yeah, 1 on 9
times n squared plus 1.
Yep.
Divided by n plus 1 squared.
Plus 1 squared.
Yeah.
Oh, 2n plus 2. And that's less than 1.
Yeah.
But greater than 0.
Yeah, so this thing goes to 1, right?
Yeah. So that thing goes to 1. And then the whole thing goes to 1 9, which is less than 1.
I found Paul online.
Paul online codes. That's the best site ever.
Alright, so that's the first 2 questions done.
Calculus.
What about
Oh my god, the
Alex?
others look so painful.
Alex.
Oh wait, that minus 2. That minus 2 looks like it's gonna mess the
So, you divide it by 1 less than the one before it, I guess.
What did he say?
1
Wait.
plus 3 and.
So 1 plus 3n becomes just 3n, and n becomes n plus 1 becomes n. And they made the question so. Wait, no, 3. Okay.
2%. 2%. Just.
Wait, what is this? I'm so confused.
Yeah.
Wait, what is Michael doing?
I'm just kind of going with it right now.
Alright.
1 plus 3 and.
Okay, I try
I
my.
noticed that the sequence converges.
Huh?
Okay, number 4
converges.
wait, number 4 combo.
Converges.
So it's kind of like in limits, you can kind of cancel this with this. Cancel this
yeah.
with this.
Is convergence less than 1?
No, it's
5 to the 1 plus n.
Cancel this
I
with
just
this.
What's divergence?
Cancel
Divergence
this
is absolute more than
with
1.
that.
Yeah.
This is the most
Equals to 1
sus.
is unclear.
Because,
2 minus 2 to the.
Is it minus 8 on 5? Is
It's sort of that like.
Minus 8.
Yeah.
Yeah, I think so.
that what you got?
Wait, hold on.
Yeah.
The cancelling is sus, but it's limits.
What number
The
are you?
cancelling
The cancelling is sus, but it
What are
seems
you?
legit.
Which number?
So this diverges.
Question number.
Okay, so that's.
Yeah.
Oh,
Yeah.
no, but
But
this equals
what if I
minus
click solution? Will they agree with us?
1 minus. Oh.
I don't know. I
Oh.
probably
What's
did
1
not.
minus 1 on n plus 1?
Show all steps.
Start solution.
Wait, yeah, the harmonic. Oh, that's why.
You need to compute.
Oh, yeah.
Yes, we did
Wait,
it.
oh, right.
Wait, no, we knew we did it before we saw the solution.
Oh, yeah, no, but
negative.
then why does,
I know, but they did absolute value.
why does that not? Oh
We
my
don't need to
God.
see the solution to know we got it. Come on, guys. What is this?
Insecure.
No, we don't need to see
Number 4
Go
combo.
back
I've
to
never done
primary
this
school.
before. Which one do we do? No.
4. This is
I've
Leon's.
done ratios.
Number 4 combo is 100 down.
Me too.
Number 4. What Leon?
Wonderful. That's they kind of.
Yeah.
Oh my god, n starts at 3. No.
Because
Starts at
because
3.
once it reaches a big enough number,
And
e to the power
and
4n
minus
gets
1
e to the
power
yeah,
four.
e to the 4n can no longer sustain power.
or either
No,
4.
the
So that's
function
just
cancels
like
out.
either 4
Yeah,
divided by n plus
In a nutshell,
1
it converges.
n minus 1. Sorry. Yeah, either 4 on n minus 1.
So this goes to 0.
Yes, sir.
Okay, there's only one more left, Daniel.
Yeah.
What you got?
Oh, good. This one goes to -1.
Oh,
Goes to -1.
Oh, sus.
oh, it's done, nice. Oh, but
Okay,
but we don't. But wait, hold
That
on.
was clutch.
Wait, but we're meant to determine if it diverges or
Yeah, so
converges.
now we
Yeah,
actually
but
gotta do it legit.
it's unclear.
Now we're gonna do it legit.
Oh no.
Wait, if it goes
Oh.
to -1, doesn't that mean each term like
Oh,
goes
it
up and
doesn't
down,
go-
up and
it
down?
doesn't go
Because
infinite.
we're not doing the absolute value, right? So like since we're doing it legit, like if it goes to -1, legit, but like
Yeah,
if it, doesn't that mean it like bounces up and down and up and down?
Yeah, so
So-
technically, so it's still converges.
you can kind of see its asymptotic shape. So it's probably is just convergence.
Oh, but
Probably is. But remember, -1 to the n on n. Does that converge?
no way.
That one converges, wasn't it?
It could, yeah, converges to like.
That one did converge.
It gets one smaller.
Yeah, it goes
Oh wait.
It gets one smaller.
Oh no, because
That's the crux of it.
That
It
one
gets
definitely.
smaller.
Actually,
What?
yeah, to be honest, that one's
definitely.
like the most obvious that it converges because each like
No,
value
but
afterwards
it's
does like
also-
6
Because you can get arbitrarily.
it does less impact on the sum itself.
Wait, like, why don't we just sum values in and see where it goes?
Well, we just know it's convergence. It does. It's fine.
You just see. You
Okay,
just
we believe. We believe.
Yeah, we would.
Okay, I trust.
we will believe.
Okay, so we're still missing a proof of this. Okay,
Damn it. This is like.
but I mean, if you can assume this one converges, then I think a proof wouldn't be too
Proof
far.
of,
Wait, does it con-
I
Huh?
mean, wait, a proof
I
of
think
the
you're
alternating
wrong.
series.
Yeah, I think it.
Does question 5 converge, Jasper?
It appears to.
It's converge.
Yeah, I think it does.
Wait,
It appears to.
wait, why is it -1 over? Wait, what? Wait, what am I reading?
Oh no, they're claiming this converges,
Yeah, because it's like 1 and 2.
Oh, yeah.
and then
Because-
I'm saying if that converges, then this
Yeah,
converges.
because it's like
The absolute value of the terms, or the theorem is if the absolute value of the terms is decreasing in the alternating series, then it converges.
you could just like
very weird.
what else?
If the absolute value of the terms is decreasing, then you kind of get an alternating thing where it narrows down to 1 point.
-1 plus 1
Ah,
and 2
Okay.
-1 and 3, so forth. And then this is like what -1 and 12.
Let me click the solution because I'm curious
Minus
now.
1 and 2.
That's what they would
And
say.
then this
like unclear.
This decreases faster than
They
like.
just say it's unclear.
Oh, if they just say it's unclear, we never see this
1 and
website again.
4.
Oh, good job. Good. They actually.
Doesn't
tried.
mean we can't determine. Yeah, exactly. Good. Maybe this site is not bad.
They actually tried the problem. Wait.
Okay, Paul's notes. Yeah, Paul's online notes.
Oh, so they just quote what Astro quoted.
Usually goes in.
They just quoted if the terms go to 0, then it converges. All right. So I mean,
So it's clearly a good website.
no. I don't know. No. It's clearly not terrible because
Terrible website would have said unclear.
they would have just been like, yeah, we cannot determine.
We did just give up. Give up.
Wait, surely we can alter code. It's like plug this into a.
It's left an exercise for it.
It's left for an X. Doesn't exercise.
Wait, what's -1 to the power of a non-integer?
It becomes 1.
Huh?
What's -1 to the power of a non-integer?
Okay, first of all, it obviously can't be like a.
1 is also doesn't touch anything.
That'll be odd.
Yeah.
Oh, that makes sense. That makes sense.
But if it's-
Okay, I'm just
If it's irrational, then I really don't know.
That's a good question. The question for Dismas.
Yeah. So that's our little the little ratio test. I don't know if you want to see this calculus. It's BC calculus.
BC.
Another
So
calculus.
I don't think it's an AP calculus.
If you
Oh.
can't solve this, you must be ashamed of yourself.
Wait, this is my jacket.
Okay.
Oh no.
BC.
What? Oh no, my pencil case is good.
What?
Man.
Actually, wait, I already thought it was the same one.
I have this BC calculus somewhere. Yeah.
Bro.
What is BC calculus as opposed to what?
It's a little bit. It's like maths extension
AD
1.
XY
calculus.
Oh,
calculus.
what's E2 maths?
AD calculus.
BC as opposed to
I don't think they have E2
Y
maths.
axis.
Oh. But where are we going to
Oh,
do
wait.
our inequality, our AMGM inequalities?
AM no.
The infinite source of AMGM inequalities.
See that's
GM with 3 terms is not in the curriculum.
Bro, rearrangement solves half the inequalities
Yeah,
in 40
exactly. I just
Wait, it says here. Let's see. Look.
Except rearrangement.
Using the ratio test, find the interval of convergence of the power series for f. See? So basically, you just the only difference is now the series depends on x, right?
Yeah.
And so you need the values of x for which the ratio test is true. No?
That is
Okay, so that's kind of something you can look forward to,
Looking forward.
Look for.
as in it's in front of you.
That is true.
Hey, stop copying me.
All right, so we have another 18 minutes.
Oh wait, I have some amazing news. I solved.
Oh, what?
I think I solved the T-set question, the geometry question synthetically. just now.
Which one?
Yes, sir.
Just
A
now.
H the A H equals 3 HQ or whatever question.
Oh, that's
Okay.
good. That's big. That's big.
Oh. Wait, do you want to see him present that?
Yeah.
Yes.
But then we're gonna have to go over time then, yeah?
Yeah. What?
So
I was doing it
he said he got a synth for the one you was trying to synth today. T11Q2.
I was doing it during the exercise. During the exercise.
Oh, what a winner.
Bro, Yasser is
my
just
Insanely.
theorem.
Yes.
It's actually